Hello all, today we are going to look at polar coordinates. Let's have a look at what is meant by polar coordinates. So far we know Cartesian plane, x and y axis. In this set of axes, we can indicate any point with two coordinates, x and a y. So we can pick here 4, 1. So that's obvious. Now what we would like to do is we would like to represent this point or set of points using a different representation. We call it polar coordinates. How it's going to work? Let me first draw a line from origin to the point. Now this point I'm going to consider first is root 3, 1. Well, that's a special point of course. I'll explain why, because it's easy to understand. Its x length here is root 3. The y height here is 1. Well, obviously, if you look at this particular triangle, this is a right angle triangle, which means I can find the length of the hypotenuse. If I call this point as A and this as the origin, I can find OA using Pythagoras, and you would end up with it to be 2 units. You square the values, add them up, take the square root. And polar coordinates mean you are going to write down the coordinate in terms of a length or rather distance which is away from the origin, or the shortest distance between the point and the origin, and the angle between the positive side of the x-axis and the line that joins the origin and the point, so OA. So that's theta. Well, if you remember exact values table, what is theta in here in this case? In this case, it will be 30 degrees, or you can say pi on 6. And then I can represent this one as r theta form, where my r is 2, theta is pi on 6. Hence, this coordinate is 2, pi on 6. Well, there's another representation. Well, it's another way of writing, not a representation, exactly the same representation, but a different way of writing. And if I look at a point on the third quadrant, let's say I'm going to consider that in pink. I'm going to extend this line until I hit the height -1. It is the mirror, or rather the opposite. If you draw a line here, just in there, and you can see these 2 points, one in pink and the one in purple now, are the mirror images of each other. Which means if I go that way, this way positive 2, let's indicate that in brown color, and this way I can treat it's negative 2. So you're going to the opposite direction. Therefore, what I can say is, I can still consider this point to be opposite of the pink point, that one. So how do I write down that in the same manner? Well, I can write down this one. Well, what is the angle here? The full angle there is pi on 6, and you can see you add a pi. So full pi in there, you're going to add it, which gives me 7 pi on 6. So simply adding a pi. And of course, because it's opposite, I could call its length is 2 but negative. So hence, we can represent either as r theta or negative r pi plus theta. Well, you think yourself now, is it the only way we can write this coordinate? Well, if you remember the repetition on trigonometric functions, you can in fact whirl around this point. So if I go around this point for another 2 pi, I'm going to repeat exactly the same point again, which means I can say in general, I can put a different color, it is written as R, then I have of course theta. What I can do is I can do 2n pi. Or, as we seen before in pink, you can say it's negative R, color didn't select, negative R, theta, and I'm going to, yes, I have 2n pi, but I also add another pi on top of that. That gives me 2n plus 1 pi. It's another way of writing, which means the point A has 2 comma pi on 6, same thing, negative 2 comma 7 pi on 6, exactly the same spot, and also you can say this is 2 comma 13 pi on 6, which means you have added a 2 pi plus 2 pi onto the first angle. What it means? It means this, in this representation, it's not unique. That's what we call non-uniqueness. You can write down this answer or that answer, but I can ask you specifically in a question, well, tell me the polar coordinates where the angle is in between 0 to pi or 0 to pi on 2. In that case, you can't put 7 pi on 6 in there. So you gotta write the one in green. So if I say, give me the coordinates in the polar form where theta is now more than pi between 3 pi on 2, that means in the third quadrant, in that case I need to write down the pink form or the pink solution, not the form. Form is exactly the same, the r theta form. I hope you understand. Now let's have a crack on few others. So there's another point. So you can go ahead, you can pause the video and go ahead and do this one. Let's have a look at using a different color. I'm going to pull this color. And I'm going to draw a line that joins origin and the point. Let's say this is B. Obviously, this is your x value, that is your y value, and then you square them, add them up, and take the square root to get the full length. Well, if you did that, what do you end up with? If the root 3 and a 1 gives you 2, and 2 times 2, that should give you 4, isn't it? If you do the maths in your head. Okay, so that's 4, and what is the angle? Now, if you look at the full height here, the height is 2 root 3, or rather if you take the height over the length or the rise over run, in this case you can say whatever tan alpha that I'm looking at, tan alpha is 2 on, or 2 root 3 on 2. So that's basically root 3. What does, what angle gives you root 3? What alpha? Well, obviously, first one is pi on 3, and then you can repeat. In this case, then we write 2 comma 2 root 3 in a polar form. It's 4 comma pi on 3. And of course, as we've seen before, in this pink version, you can write down different angles and negative values for the 4. So that works. And then the final one we are going to look at is the negative 1 comma 1. It's another unique point where it is associated with a nice angle, exact value angle that we can talk about. Let me draw a line here. If I draw that line, it is 1, 1, which means this angle should be 45 degrees. What does that mean? Well, I'm going to look at the full length. Full length is root 2. 1 square plus negative 1 square square root. So there. That's root 2. Angle is 45 on this side, pi on 4. And the diagram is getting a little messy, but you understand what's happening. Therefore, I need to first figure out what is the angle between the x-axis, positive direction of the x-axis, just in there, that way, and then between that line. So that's the full angle here, which is pi minus pi on 4. So it's 3 pi on 4. Hence, I can write down this as root 2, comma 3 pi on 4. Again, you can add pi onto this. and write down negative root 2, comma, you add a pi onto that, leave as 7 pi on 4 as your type of a pink type answer with a negative r in it. I hope you understand, and then also you understand the repetitions, which means it is not unique, non-uniqueness of this representation. And the work plan is 15G first 3 questions. Once you've gone through that one, we can obviously talk about representing graphs in polar form or sketching graphs using polar form. They're pretty cool graphs. We'll get back to that soon during our next lesson. But for now, yeah, go ahead and work on 15G. Thanks all. Have a good one.